Astronomers and scientists keeping a very close eye on a strange traveler that began its journey to our solar system.
A faint tremor of concern rippled through the planetary science community the moment mission controllers disclosed a chilling fact. The James Webb Space Telescope, JWST, had detected an unusual dynamical signature in the trajectory of a newly discovered interstellar visitor, 3I Atlas. For decades, we thought of these cosmic travelers as passing curiosities. We'd seen them before, the mysterious 1I ʻOumuamua and the distant 2I Borisov, objects that drifted through our solar system on brief cryptic passages before disappearing back into the abyss between stars. But the Webb data hinted at something radically different from those previous wanderers. Something that turned the very concept of a celestial visit into a catastrophic event. Instead of passing harmlessly through the solar system, as interstellar bodies typically do, 3I Atlas appeared to be deviating from the graceful, open hyperbolic path. This was the first chilling hint of the disaster to come. The orbital anomaly exposed. It's not passing by. Orbital analysts detected the warning signs first, a subtle yet persistent change in the object's velocity vector. This anomaly was too faint for ground-based telescopes, but was undeniable in the James Webb Space Telescope's JWST infrared data. At first, specialists across NASA were convinced the unexpected perturbation had to be a simple measurement error, spending days recalculating the object's path. Yet Webb's instrumentation proved precise, and the anomaly held firm. As the refined orbital solution took shape, it stunned veteran dynamicists. The trajectory of 3I Atlas was resolving into something catastrophic. It was not merely passing through the solar system, it was drifting onto a course that would take it perilously close to Mars. The realization grew quickly. The object was heading straight for a collision. This was the point when NASA broke its carefully maintained silence. With the Webb team providing a data set too precise to ignore, there was no longer enough uncertainty to dismiss the result as a miscalculation. The impact was real. Would you like me to elaborate on the composition of 3I Atlas or the scientific opportunities this collision presents? 3I Atlas, a messenger from another star. The object 3I Atlas defied traditional categorization, showing a structural composition markedly different from previous interstellar visitors. Webb's infrared spectroscopy revealed a surface enriched with complex carbonaceous compounds, alongside regions exhibiting unnaturally reflective metallic signatures. Unlike the cometary coma of 2I Borisov or the flat profile of 1I, ʻOumuamua 3I Atlas radiated heat unevenly, and its albedo, reflectivity, fluctuated in unexpected, almost pulsing rhythms with its rotation. This thermal signature hinted at an extreme internal structure, perhaps a dense rocky core, an icy matrix insulated by dust, or extreme heterogeneity. It straddled categories, being neither purely comet nor purely asteroid, suggesting it represented an entirely new class of interstellar debris forged under conditions distinct from our own solar system. Would you like to move on to the scientific opportunities presented by the collision? The scientific gold rush, opportunity, not threat. Scientists were careful to emphasize that Mars, uninhabited and geologically diverse, would bear the brunt of the impact rather than Earth. Yet the implications stretched far beyond concerns about planetary safety. This was not a threat, it was an extraordinary scientific opportunity. The scientific stakes alone were enormous, offering a once-in-human-history chance to study what happens when a body forged beyond the sun's influence meets the rocky crust of a terrestrial planet. By analyzing its incredible speed and angle of approach, astrophysicists traced 3I Atlas backward through the galactic plane. The model suggested it had wandered for millions, perhaps hundreds of millions of years, before encountering the sun's gravitational field. Its composition, rich in heavy elements, supported the idea that it had formed around a star older and richer than our own Sun. This meant the object carried minerals shaped in environments that predated the solar system and possibly bore chemical signatures unavailable anywhere else within local space. Its collision with Mars would scatter this utterly alien material across the Martian surface, embedding traces of its distant origin into the red planet's regolith for future missions to uncover. This impact, though violent, was the ultimate sample delivery mission, offering the most pristine material from another planetary system ever accessible to science. Impact scenario: what Mars will experience. Current estimates place 3I Atlas at several hundred meters in diameter, though the irregular thermal readings suggested its size could be larger. If composed of dense material, the kinetic energy released upon impact would be equivalent to many thousands of megatons of TNT. Mars, with its thin atmosphere, would offer little resistance, allowing the object to strike the surface nearly at full cosmic velocity. The resulting crater would dwarf those created by most recent asteroid impacts in the solar system. The sheer violence of the event held immense scientific potential. Planetary geologists anticipated that the collision could excavate deep subsurface layers, revealing materials otherwise inaccessible without heavy drilling equipment. For astrobiologists, the potential was even more tantalizing. The immense pressure and heat could crack open subterranean reservoirs of water ice, releasing fluids and minerals that interact in dynamic ways. The sudden influx of energy might create short-lived hydrothermal environments, regions where liquid water coexists with mineral-rich substrates. This would mimic conditions believed to foster molecular complexity, offering a sudden, brief observational window into processes that might sustain ancient microbial life hidden beneath the surface. The Martian War Room. Missions prepare for the blast. The collision transforms the entire red planet into an impending natural experiment that humanity can monitor with modern scientific tools. Robotic missions already operating on Mars entered the discussion immediately. Rovers and landers positioned across the planet would detect seismic waves from the impact, providing an unprecedented data set on Mars's internal structure. Seismometers could record vibrations passing through the mantle, crust, and core, revealing the planet's composition with new precision. Orbiters would photograph the evolving shape of the massive dust plume, measure atmospheric disturbances, and map thermal signatures across the planet. At the same time, mission planners contemplated launching dedicated probes. A rapid response flyby mission, though ambitious, was seriously debated. An intercept course for 3I Atlas on its approach. Such a mission would capture high-resolution images and spectral data unavailable from Earth or Webb alone. Even a brief flyby would provide invaluable information, guiding future strategies for intercepting or redirecting such high-velocity bodies should one ever threaten Earth directly. The global scientific community was mobilizing to watch planetary geology in action. The final days. The unsettling trajectory. Despite the consensus among computational laboratories around the world, the orbital anomaly remained the most unsettling component of the discovery. For 3I, Atlas to deviate so dramatically required either an external push or an inherent force affecting its movement. And chillingly, the deviation appeared to increase as the object approached the inner solar system, defying simple explanations like outgassing. Even as scientists prepared for the impact, a narrow range of variation in the models allowed for an outlier projection. This faint possibility hinted that the object's trajectory could shift slightly during its final months of travel, either deepening its path into the Martian surface or, incredibly, glancing past the planet by a slim margin. This latter scenario was equally intriguing. A near miss could dramatically alter the object's orbit, potentially capturing it temporarily into the solar system or sending it on a different outbound path. A second natural experiment. but the prevailing solution still pointed strongly toward a direct encounter. The projected intersection point between 3I Atlas and Mars lay within a corridor only a few thousand kilometers wide. Considering astronomical scales, this accuracy means the probability of a collision is extremely high. A new view of the cosmos. The revelation of 3I Atlas closing in on Mars reshaped the way scientists discussed both the past and future of the solar system. For centuries, humanity viewed our domain as relatively isolated. Yet the arrival of a foreign object on a collision trajectory underscored the reality that the solar system is not sealed off from the broader galaxy. Objects from distant suns can wander into our domain at any time, carrying with them the physical and chemical signatures of their origins. The cosmic neighborhood, once imagined as spacious and tranquil, now appeared more interconnected and unpredictable. This impact will force us to realize that planetary evolution might be influenced not only by local debris, but also by the quiet drift of matter across vast distances, a cosmic exchange of wandering fragments. Mars is about to receive a chilling message, carried across the galaxy for millions of years, written in the language of minerals and momentum. For the first time, humanity is preparing to document this profound interaction in real time. If you found this exploration of an impending interstellar collision fascinating, please give this video a like and subscribe to Mysteries Uncovered Files for more deep dives into the unknown corners of science and the cosmos. What do you think Mars will reveal after the impact? Let us know in the comments below.